welcome to today's physics class. Today's physics class is the continuation of our last class. In our last class, we stopped at examples on the movements of a force. So today we will continue with more examples. So today we will start with example 8. Now, a uniform board of weight 40 Newton supports two weights 800 Newton and 350 Newton. If the 800 Newton is 1 meter from the center of the board, determine where the 350 Newton weight will be placed from the center to balance the system. Now let's look at our system. We have this. Now we were not told the length of the board, but we always know that the weight, since the board is uniform, the weight will be at the center. Now we have the weight 800 Newton. Now notice that we're told that support two weights, not rest on support. Support two weight, that means the weights they are acting on the beam, so they are all acting down. Now from the 800 Newton to the center is 1 meter. Now we do not know the distance of the 350 Newton weight from the center. The only place we can take moment in this case, let's take moment at the center, since we don't know the center, the distance to the center. Now we will have this 800 Newton. We'll take moment at the center, and we will have the 350 Newton. Now the distance here is 1 meter, and the distance here is s. If you drag this force in the direction to the point of moment, it's giving us anti-clockwise moment. If you drag the 350 Newton in the direction to the point where we are taking moment, is giving us what? Clockwise moment. So let's go. Clockwise moment will be 350 times s. Anti-clockwise moment, what would that be? That would be 800 times 1. That is 800 Newton meter. But according to the principle of moment, the clockwise moment must be equal to the what? Anti-clockwise moment. That would be 350 s will be equal to 800, where s will be 800 divided by 350. 800 divided by 350 will give us 2.2857 meter. So the distance is approximately 2.29 meters. Now let's look at another example. A uniform beam of length 6 meters long rests on support P and Q with reaction 130 Newton and 100 Newton respectively, placed left and right 1 meter from each end of the beam. Now let's have our beam. The beam is what? Is uniform, number one, and it is 6 meters long. So the weight of the beam will be at the middle. We don't know that weight. Let's call it W. This will be 3 meters. Now they say rest on support P and Q, not support P and Q, but rest on what? Support P and Q. So they will create what? A reaction. Now, reaction are always opposite to what? Action. So the reaction will be up since the action is down. So that will be 130. That will be 130 Newton This is a 1 meter, and the second one will be 100 Newton 1 meter. Then mass is 10 kg placed near P. This is towards P. Now 10 kg, 10 kg is 100 Newton. So I'll say 10 kg is 100 Newton. Now the next second one is 8 kg, which is what? 80 Newton. Now, okay, let's repolish our diagram. Let's draw our diagram. Now we have here 100 Newton. We have here 130 Newton. We have here weight. This place we have 100 Newton, and here we have 80 Newton. Now let's look at our distance. From 100 Newton to 130 Newton is actually 1 meter. This is 1 meter. The center is 3 meters. So from the 130 Newton to the weight is what? Is 2 meters. From 100 Newton to 130 is 1 meter. From 130 Newton to weight is 2 meters, making 3 meters. Now from 80 Newton to 100 Newton is 1 meter. So from 100 Newton to weight will be also what? 2 meters. Now, so let's go. Now we will choose a point where we take what? Our moment. We can take moment. We cannot take moment at the center because we will be losing the weight W. So let's take moment. Let's take moment at where? Let's take moment. Now there are two ways we can just apply this, because the forces are parallel coplanar forces. That will make our life very easy, but we solved it in two ways. Now, since the forces are parallel coplanar forces, the sum of the forces going up must be equal to the sum of the forces coming down, because they are parallel coplanar forces. Let's try that. The forces going up are 130 plus 100, because the forces coming down is 100 plus weight plus 80. This will be 230 is equals to 180 plus weight. So weight will be 230 minus 180. 230 minus 180, that will give us 50 Newton. Or give us 50 Newton. So the weight is 50 Newton. Now we can take moment. Now let's say we can use the moment method. Let's say we are taking moment at the 100 Newton weight. So that there will be a knife edge there. Let's say we are taking moment there. If we are taking moment there, if we drag the 330 Newton weight or force in the direction to the point, it moves what? Anti-clockwise. If you drag the weight to the point, it moves what? Clockwise. If you drag the 100 Newton to the point where we are taking our moment, it moves what? Anti-clockwise. If you drag the 80 Newton, it moves what? Clockwise. So the 130 Newton creates anti-clockwise moment. The 100 Newton creates anti-clockwise moment. But the weight creates clockwise moment. The 80 Newton creates clockwise moment. So let's go. Our clockwise moment will be W to the point, that's 3 meters. That will be 3W plus 80 Newton to the point, that's 6. That will be 80 times 6. So what would that give us? That will be 3W plus 80 times 6, that's 480. Now let's go for anti-clockwise moment. Anti-clockwise moment. Now that will give me 130 Newton to the point of moment is 1 meter. So that will be 130 times 1 plus 100 to that point. That will be 5. 2 meter to the weight and 3 meters to the weight. That's 5. That will be 100 times 5. That will be equals to 130 plus 500. That will be 630. Alright, so let's equate 3W, that's clockwise moment equals anti-clockwise moment, is equals to 630. So 3 is equals to 630 minus 480. 630 minus 480, that will give me 150. 150. So we can say weight W is 150 divided by 3, and that is 50 Newton. So you see that in this case, applying the rule for parallel coplanar forces simplify our expression. Now let's look at another question. In the diagram above, a rod 50 centimeters long of a uniform cross section is suspended horizontally on a fulcrum F by the action of the forces. What is the weight of the rod? Now, if we go through a diagram again, let's have a simplified version of that diagram. We have a weight here, which is 200 Newton. Now, we have the pivot. This is at 5 centimeters. Now, we have a pivot, which is at what? 15 centimeters. The weight will be at the middle. The weight, W, will be at the middle of 50 is 25. And we have another weight here, 40 Newton, which is at what? 45. Now, the 200 Newton, if we drag it in its direction towards the point where we are taking our moment, we take our moment at the fulcrum, it's creating what? Anti-clockwise moment. If you drag the weight W towards the point, it's creating what? Clockwise moment. If you drag 40 Newton in that direction, it's creating clockwise. So we can see that the 200 Newton create anti-clockwise moment, while W and 40 create what? Clockwise moment. Now, let's go for anti-clockwise moment. Anti-clockwise moment will be 200. Now, from 5 to 15, that's 10. Now, notice that I did not convert to what? To meter. We'll still get the same answer. So that will be 200 times 10. So that will be 2000. So what will be the unit now? That will be Newton centimeter, because our distance is centimeter. Now, clockwise moment will be what now? It will be from 25 to 15 is also what? From 15 to 25 is 10 centimeter. So that will be 10 W, that is weight times distance, plus from 45 to 15, that will give us 30. So that will be 40 times 30. Now 40 times 30, that's 1200. So we are going to have 10W plus 10W plus 1200. So we are going to have anti-clockwise moment equals to clockwise moment. So 10W plus 1200 is equals to 2000. So 10W is 2000 minus 1200. So 2000 minus 1200, that's 800. That's 800. So divide both sides by 10. W is equals to 800 over 10. That will be 80 Newton. So the weight of the beam is what? 80 Newton. Now let's look at now all the questions we'll be taking, they are parallel coplanar forces. Now let's look at this is non-parallel what? Coplanar forces. Now if you look at the diagram, you will see that the tension is inclined at an angle. So the first thing we are going to do is to what? Is to resolve that force. So this will be T sine 30. T sine 30. Now here will be T cos 30. Now because T cos 30 lies on the plane, it will not create what? Moment. So let's draw our diagram again. We have here T sine 30 and the distance is 20 centimeters. Now we have a force here. We have a force here, and that force is what? F. And the distance is 30 centimeters. So let's go through the question. A uniform light beam XZ rather, is aimed at S, and kept in equilibrium by the force T and F as shown in the diagram above. If SO is 20 centimeters, OY is 10 centimeters. Express T in terms of what? F. We do not know F. Now let's take moment at the hinge point, which is point what? S. Let's take moment from that point. If we take moment from that point, if you drag T sine 30 in the direction to the point we are taking moment, it's creating what? Anti-clockwise. If you drag F in the direction to the point, it's creating what? Clockwise moment. So clockwise moment, what will it be? That will be F. From F to the fulcrum is 50 centimeters. That will be 50 F. That will be 50 F. Anti-clockwise moment, that will be 20 times T sine 30. That will be 10T. That will be 10T. So let's go. 10T is equals to 50 F. So T is 5F. T is 5F. That is option D. Let's look at one more example. A uniform meter rod of weight W is maintained at the equilibrium by two cords having tension of R, P, and T respectively as shown on the diagram above. Find the weight of the rod and the tension RP. Now, let's look at this question. First of all, it is what? Non-parallel coplanar forces. So since it's a non-parallel coplanar forces, the very first thing we do is to resolve the what? Is to resolve the forces that are inclined, so that we can convert the system from non-parallel coplanar forces to what? Parallel coplanar forces. So we have T sine theta. Now, here will be RP sine alpha. Okay, so our system will now be balanced. Let's redraw the diagram again. We have our weight here, which is W. Now we have our force here, which is RP sine alpha. And from this point, there was a fulcrum even placed here for us to make life easy. That is L1. And in the diagram, L1 is what? L1 is 30 centimeters. L1 is 30 centimeters. Then we have T sine 30 there. Now, from RP to T is L2. Now, but from RP to W is L. So from W to T, that will be L2 minus L1. L2 is 72. So 72 minus 30, that will be 42. That will be 42. So if we take moments at RP sine alpha, we will discover that the RP sine alpha will not create what? A moment. So T sine theta and W will be the one creating moment. If you drag T sine theta towards the fulcrum, it's moving what? Anti-clockwise. If you drag W towards the fulcrum, it's moving what? Clockwise. So our clockwise moment will be just 30 W, which is W times 30. Our anti-clockwise moment will be T sine 30, T sine theta, not sine 30, sine theta times 72. So that would be 72 T. And notice that theta is 30, so that would be what? Sine 30. So that would be 36 T, because sine 30 is half. 72 divided by 2 is 36. Now let's go. Clockwise moment is equal to what? Anti-clockwise moment. Now, so we are going to have 30 W is equals to 36 T. Now, that will be T itself in the question. T is what? 50 Newton. So that will be 36 times 50. So W will be 36 times 50 over 30. So 36 times 50 divided by 30, that will give us 60. So the weight is what? Is 60 Newton. Now, we can also apply, let's find ROP now. Actually, the original question just find the weight, but I want us to also find ROP. You know, we can apply parallel coplanar forces. Some of the forces going up is equal to some of the forces coming down. So, and okay, we do not know alpha also. We don't know alpha, we don't know RP. So, which means that we will need the angle alpha for us to calculate. But let's just calculate in terms of that. So, we get RP sine alpha plus T sine theta will be equals to what? The weight coming down. So we don't know RP and we don't know what? Alpha. We have two what? Two unknown. So it's either they supply us with alpha in order for us to find what? RP. We know T, we know theta, we know W. So we can only find R sine alpha only. We can't find the rest. Now if we were given our either RP or alpha, we could have calculated one of them. So we have we are taking various questions on what? On moment of a force. So we will just be talking about our last class, we're talking about equilibrium and stable equilibrium, all the rest like that. That is what we are supposed to deal with in our last class. So we have one more class to finish this thing. So go through it, solve various examples, and make sure that you grab everything. Thank you.